Today we will be looking at grade 9 geometry of 2D shapes worksheet. Okay, let's go straight to the first question. A, B, C, D is a parallelogram. Okay, and there's a few things we know about the parallelogram is that the opposite sides are parallel. Okay, that will help us to find x. So if you look at this triangle over here where x is, okay, we need to find B2 or B1 in order to find x. But we are given this 30 degrees over here, and we know that that and that line is parallel. And the moment we see that, we can see that B2, B2 is equal to 30 degrees because of alternating angles. Okay, once you have this bit of information now, that's 30 degrees, we can use one of my previous videos properties of a triangle, which states that this exterior angle over here is equal to the two interior opposite angles added together. So we can go ahead and say that 142 degrees is equal to 30 degrees plus x. And your reason is exterior, interior, opposite. Okay, once you have that, you can then solve for x and say 142 minus 30 is equal to x. And from this, you can simply see that 112 degrees is equal to x. Okay, or x is equal to 112. To then quickly find these other angles over here, we know that this is alternating as well. Okay, just to fully find all the angles, but we found x already. That's alternating, so that means this will be 112 degrees because of that alternating angles over there. And then we can find this angle using triangle properties, knowing that all three angles add up to 180 degrees. Okay, and you can find that for yourself. That should be quite easy over there to find those angles. Let's have a look at the second question. Okay, as you can see again, ABCD is a parallelogram. So I can go ahead and state that the opposite sides of the parallelogram are parallel. Okay, so firstly, we need to find x and all the interior angles for this. Okay, so we can again use alternating angles to find A1. Okay, and then A1 is equal to x. So we can state that A1 is equal to x because of alternating angles. Okay, and then once you have that x over there, okay, we look at this triangle over there and we use our triangle properties. We can say that 120 plus x plus 2x is equal to 180 degrees. That's angles in triangle equal to 180 degree property. Our like terms we keep to the left. 3x is equal to 180 minus, we take 120 over, and then we have 3x is equal to 60 degrees, and to find x we divide by 3. X is equal to 20 degrees. Right, now that we have x, we know that this is x, that angle is x, so we can say that angle A1, which is shown as x, is equal to 20 degrees because of the information we just found out. That means this is 20 degrees over there, and this is 2x, meaning 2 times 20, and 2 times 20 is 40 degrees. Okay, we also know, because of alternating angles, that A2 is also 40 now, and then opposite angles of a parallelogram are equal, so that's also 120. Okay, let's have a look at our third question. ABCD again is a parallelogram, and there we have that diagram. Immediately what catches my attention is these two vertically opposite angles. Okay, I will say 80 is equal to 140 degrees minus 2x. The reason is vertically opposite. Okay, then I have this equation. I have 80 equals to 140 minus 2x. 80 minus 140 equals to minus 2x. I've taken the 140 over. Okay, and 80 minus 140 is minus 60 is equal to minus 2x. And then I divide by minus 2, I can see that x is equal to 30 degrees, so 30 degrees is equal to x. Okay, now that I have that bit of information, I'm going to find the interior angles. I know x is 30, so I can replace this x over here with 30 degrees. Okay, and if I look at this angle over here is 140 minus 2x. Okay, so if I can see that that angle over there is 140 minus 2x, let me just use that over there. X is 30, so I'll replace the x with 30. So I have 140 minus 2 times 30 is 60 degrees, and then I'm left with 80 degrees. Okay, 140 minus 60, that is 80 degrees. I can then replace this is 80. That's also verifying that that is 80 as well. Okay, and opposite angles of a parallelogram are equal, so I'll say that's 80 as well. And alternating angles, that is 30 as well. And we can again use our triangle properties to find the last angle either of this triangle or of that triangle. Okay, and that would be 180 minus 80, which is 100, minus 30, which is 70 degrees. So that is 70, and that is 70. Okay. Okay. Looking at question 4, ABCD is a rhombus, and again, we need to find x and all the interior angles. Now, there's something that we need to know about the rhombus is that the diagonal of a rhombus the diagonals of the rhombus bisects the angles. Okay, so then this angle over there, since it is bisected, would equal to x. Okay, so we can say that C1 is equal to x, and we can just write rhombus properties or rhombus diagonal. Rhombus I'm going to use. Okay, then I can say that those lines are parallel. Okay, also these two. That's just the properties of rhombus. Just indicate like that. Now we can see that we can use actually a different law or property is co-interior. So I'm going to say, if you look at that angles over there, is 50 plus x is equal to 180 degrees, and we're using co-interior. And then we have 2x is equal to 180 minus 50. 2x is equal to 130, and we divide by 2. X is equal to 65 degrees. Okay, now that we have this bit of information, I can go ahead and replace this x. Okay, with 65, this x, 65 as well. Okay, That would then mean that looking at alternating angles, this would be 65 too, due to alternating angles, and this way too would be 65 degrees, and also because that diagonal bisects as well. And then opposite angles, again, of a parallelogram or of a rhombus also, they are equal. Okay, looking at question 5, we need to calculate the size of x and all the interior angles. If we look at this triangle again, if you remember my previous video for triangle properties, we know that the exterior angle of a triangle is equal to the two interior opposite angles. So we can go ahead and say 6x minus 15 degrees is equal to 3x plus 2x plus 12. Okay, then we're going to have our reason is exterior, interior, opposite. Okay, then we have this equation. So we're going to have all our like terms on the left, 6x, the inverse of that minus 3x minus 2x is equal to, we're going to take the 15 over, we have 12 plus 15. This gives us x, and this gives us 27 degrees. Then we need to find angle G. Angle G would be 3 times x. Okay, let me just quickly do that. G would be 3 times 27, that would be 81 degrees. And for angle F, we have 2 brackets 27. We could have also indicated brackets over here, but it means the same thing. Brackets plus 12, and that is equal to 66 degrees. So we can go ahead and replace this as 81, that as 66, and to find this angle, indicate that 66. This angle over there, again, indicate that as E1. We can say that E1 is equal to 180 minus 66 minus 81, and that's equal to 33 degrees. Okay. Your reasoning here is angles in a triangle equal to 180. Again, I'm just quickly going through this because it is the triangle property, and I'm sure we're all familiar with the angles inside the triangle equaling to 180 degrees. Okay, let's have a look at number 6. It says calculate the size of x again and all interior angles. So if we look at this triangle again, it's an isosceles triangle, and we know that the opposite sides of an isosceles triangle has opposite equal angles. So if that's an equal side with that opposite angles are equal, so that would be 2x. So you can say C1 is equal to 2x. Your reason is isosceles. Okay, and then we can find x by adding all of those angles. So we have 5x plus 2x plus 2x added up to equal to 180, and your reason is angles in a triangle add up to 180 degrees. And again, this gives me 5, 6, 7, 8, 9x is equal to 180 degrees. And again, we divide by 9, divide that by 9, and we have x is equal to 20 degrees. Okay. Once we have that, we can now replace that x with 20. So 2 times 20 is 40. So we have 40 over here and 40 over there. And 5 times 20 is 100. Okay. Now we don't know these interior angles, but we can simply find D2 using the properties of a straight line. So I'm going to quickly do that. So we have D2 is equal to 180 minus 40, angles in a straight line. I'm just going to quickly go over that. D2 is equal to 140 degrees. That's 140 over there. And if these two angles are equal, I'm just going to give them a letter and say Y. Okay. So we have two ways to do this. We can use the exterior equals to interior opposite. Okay. And or we can use the triangle properties. Okay, either way we should come to the same answer. I'm going to use the exterior angle rule. So 40 equals to y plus y, and interior is my reason. Now 40 equals to 2y and y equals to 20 degrees. That means this is 20, that's 20, and that is 20 degrees. And we can double check that by adding those angles in this specific triangle. 20 plus 20 is 40, plus 140 is 180.